Okay, so here is a review on what we've learned about probability so far in Chapter 7 and a preparation for your essential skills test. It's the sixth one so far, and it's on probability and expected value. So we're going to cover those things in this little worksheet here. Please try the problems on your own first using the rules specified here. So like here I have the addition rule, okay? Use that to try to solve these problems, but of course use my video to watch how the problems are correctly solved and to see if you did your problems correctly, okay? So here, the first one says, a survey of high school seniors found that, let's start highlighting, that 42% take AP Calculus, 34% participate in the band, and 28% do both, okay? So then it asks us, what is the probability that a randomly selected senior takes AP Calculus or participates in the band? So here, as soon as I see the or, I know that it is the addition rule, okay? So here what we can do is we can set it up in words. So we can say, all right, what is the probability of AP Calc, of a student being in AP Calc, or a student being in the band? So a student that's selected could be in both of them, right? But if I were to add together the probability of AP Calc plus the probability of band, any student who is in both AP Calc and band is going to be double counted here. They're going to be counted once here and once here in that probability. So that's why we have to subtract out those students just one time. We have to subtract out those students who are in both because they're double counted here. So if we subtract them out once, then they're only counted for once and our data is not skewed, okay? So to find this probability of AP Calc or band, this is our goal here, okay? This is what we want. So what we can do now is put in the probabilities that we know. So we know that 42% take AP Calculus. So the probability that a senior is in AP Calc is 42%. So you guys see here, a common mistake I see students do is they keep the P, but that's not correct. This would be saying the probability of 42%. But no, we know that the probability of AP Calc is 42% of a student being in AP Calc. So that's where the 42% goes here, okay? And then participating in the band, the probability of a student participate of a senior specifically, of a senior participating in the band is 34%. So we're going to write 42% plus 34%, and then minus the probability that a student is in both so that they're not double counted since they're already double counted in the AP Calc statistics or the stat probability and in the band one, right? So the probability that there's a student who's in both is 28%, because we know 28% of them do both AP Calculus and band. So if I were to select a random student, there's a 28% chance that I'm going to grab a student who is in both AP Calculus and in the band. Okay, so now we have to just simplify. Whoops, sorry, screen went a little crazy there. So here I'm just going to duplicate this because that's what we're solving for. So 42 plus 34, I'm going to do this in my head. 42 plus 34 is 76 minus 28. 76 minus 28 is 48%. So our answer that we choose a person at random, a senior at random, who is in AP Calculus or the band, and they could also be in both, right, is 48%. So this is our answer for this problem here. Okay? So again, make sure that you pause the video. If you watch this before trying it on your own or before doing a problem on your own, pause the video before you try number 2 and try it out, okay? Number 2 is a little bit different though. So this one, we're gonna have to set up fractions. So we know that the total number of students or of participants in this study, if you will, in a group of 35 children. So 35 is the total. We know that 10 have blonde hair, 14 have brown eyes, and four of them have both blonde hair and brown eyes. Okay? If a child is selected at random, find the probability that the child has blonde hair or brown eyes. So that or, again, tells me that it is addition rule. So I can set this up and write, okay, so I need to find the probability of blonde hair or brown eyes. Okay, so this means that following up above, I should have written this a little bit more clearly, I apologize. So here, up here, the AP Calc, that one went first just because that's the A, right? So the A there. And then the band, right, was second, because that's the B. And then both of them was the last one there. So the probability of both of them is there, which I just realized I color coded wrong. It should be blue, not yellow. My bad. Okay. So let's do the same thing here. So the probability of the event A is blonde hair. So I'm just going to write right here, probability of blonde hair of a student out of that group if I select a random one having blonde hair. Okay. Plus the probability of event B, which in this case is the brown. All right, is a student having brown eyes. So brown eyes minus the probability of them having both brown hair and, or I'm sorry, blonde hair and brown eyes. Okay. So let's go and see here. For this probability, I'm going to go ahead and select this because it's the same thing. Okay. The probability of a child being selected who has blonde hair is 10, but not 10%. It's 10 out of 35 students. So if it's a percentage like up above, you don't have to write it as a fraction because we know it would be 42 out of 100 students. 42% is always out of 100. Anything in percentage is out of 100. If there were 100 students there, 42 of them would have been an AP Calc at number 1. But in this case, they told us the total was 35 here in a group of 35 children. So we have to write them as fractions. Okay. So here I have 10 out of 35 for blonde hair. Now for brown eyes, 14 out of the 35 children have brown eyes. That's what would be event B in the little formula. And let's see here. We have to take out the students who have both blonde hair and brown eyes. So in this case, it says 4 have both blonde hair and brown eyes. So I'm going to subtract 4 out of the 35. Just because, once again, all the students who have blonde hair are counted here, regardless of their color of eyes, and all the students with brown hair are counted here, regardless of their color of eyes. So I have to take out those students who were double counted because these students have both blonde hair and brown eyes. Okay? So if you were to add 10 plus 14, should get 24, minus 4 will be 20. So now we know that the probability of one of those students being selected at random and having either blonde hair or brown eyes is going to be 20 out of 35 students. Now to find the percentage here, what you can do is divide, go to your calculator here, we can do 20 divided by 35, and then we multiply that answer by 100, and that'll give us the percentage. And you can round this to the nearest hundredth. So we go from the decimal to the percentage. So this is about equal to 0.5714, which would be 57.14%. So we have a 57.14% chance that we would select a child with either blonde hair or brown eyes. They could have both, remember that, out of a group of 35 children. Okay? So now let's go on to number 3, and please make sure that you try this because I did show you how to do this one. So definitely try this one on your own for number 3. Okay? All right, so a sample of automobiles dealerships found that 19% of automobiles sold are silver. All right, so I'm going to start highlighting with my colors here. 19% of automobiles sold are silver. 22% of automobiles sold are SUVs. And 16% of automobiles are silver SUVs. So you notice there that's the both statement. Because the first one was just silver, the second one was just SUVs. Now both of them is 16%. Okay, so we know that the addition rule is the probability of A or B, which is equal to the probability of A plus the probability of B minus the probability of both A and B. Kind of jumped the gun there, but the reason why we're going to use this is because it says, what is the probability that a randomly chosen sold automobile is silver or an SUV? This or tells us that we have to use the addition rule, which is up above here. Okay, so this addition rule, I'm just going to add my color coding there. Probability of event A, so the A would be whatever word is put here first. Okay, so that's the A. So here what we'll write is the probability of it being silver, okay, or then the probability of the B, okay, event B is just the second event that's happening. So in this case, it's if it's an SUV. So it's silver or an SUV. Okay, and of course, like if we were to grab a silver automobile, it could be an SUV in this count that we're about to do. We just have to subtract out both of them so that we don't double count them. So here we have the probability of it being silver plus the probability of it being an SUV minus the probability of it being both silver and an SUV. Okay. So I'm just going to color code a little bit more here. And again, so here, if I were to think about all the cars or all the automobiles there that are silver, okay, one of those automobiles could be an SUV, right? Same thing here. If I were to look at all of the SUVs that are there in the lot, one of them or more could be silver. So that's why we have to subtract out the possibility of it being both, because they are double counted here and here. So any silver SUVs are counted here underneath the probability of an automobile being silver, and any silver SUVs are counted here under the probability of it being an SUV. So that is why we have to subtract out the probability of both of them. Okay, so I'm just going to go ahead and take this. This is what we're solving for. We know that the probability of it being silver is 19%. The probability of it being an SUV is 22%. The probability of it being a silver SUV is 16%. Okay? So if we do this math, see what we get here. 19 plus 22 will be 41, minus 16 should get 25. You can also do 19 minus 16 is 3, plus 22 is 25%. But once you solve that, you should get 25%. So we have a 25% chance of choosing at random a silver automobile or an automobile that is an SUV. Okay. All right, so let's move on here. These are in decimals. So decimals also means we do not have to write it as a fraction. The only thing we have to write as a fraction is if it gives us a total number, just like in number 2. Here it told us the total was 35 children. That was our sample that we were choosing from. So in a group of 35 children, 10 have blonde hair, 14 have brown eyes, 4 have both blonde hair and brown eyes. Okay? So here it says, Amber, a college senior, interviews with Acme Corp or Corporation and Mills Incorporated. The probability of receiving an offer from Acme is 0.35, or that's technically 35%, right? But 0.35 is totally fine as well. From Mills is 0.48, and receiving an offer from both of them is 0.15. Find the probability of receiving an offer from either Acme or Mills Incorporated, but not both. Now, some students in the past have gotten mixed up with this part, but not both. That's not to trick you or anything, it's to actually make you realize, like, oh, they already told me both, though. Both is 0.15, right? You guys already know that the probability to get an offer from both of them is 0.15 or 15%, 15 hundredths. Okay, so I'm going to go ahead and copy this here and put that there. This is the addition rule. And since it says or, that's how I know I'm using the addition rule with this probability problem. Okay, so here we have the probability of either the Acme Corporation or the Mills Incorporated. Those are our two options here. So what I'm going to do is go in color code. So Acme, we'll color code with orange. So the probability of receiving an offer from Acme is 0.35. And from Mills Incorporated is 0.48 or 48 hundredths. Okay, so here I always like to write it out in words. So first we have the probability of receiving an offer from Acme Corporation plus the probability of receiving an offer from Mills Incorporated minus the probability of receiving an offer from both. Okay, so I'll go and color code these real quick. All right, so now we just have to plug in the probabilities or replace the probability of Acme with the actual probability. So to receive an offer, remember to pause the video. Try this on your own if you have not yet. Do it on your own. So the probability of receiving an offer from Acme is 35 hundredths. The probability of receiving one from Mills is 48 hundredths. And the probability of receiving one from both is 15 hundredths. Okay, so I'll go ahead and color code again for you, just so you can see it. Those are where I got those numbers. All right, so if we were to add those together, we have 35 hundredths plus 48 hundredths, 83 hundredths minus 15 hundredths. 13 minus 5 is 8, so we have 68 hundredths, which we can also rewrite as a percentage. I think a lot of students prefer percentages for probability. It just kind of makes it a little bit easier to think about and to visualize. But either of these answers would be correct. They are equivalent. Okay? So she has a pretty good chance of getting an offer from either Acme or Mills. 68% chance. All right. This one always would. I think we might have done this one together actually at the beginning of the semester. But so one card is drawn from a standard deck of cards. What is the probability it is an ace or red? Okay. First of all, you need to know how many cards are in a standard deck of cards. I believe it's 54. Let's go see real quick. How many cards in a deck? 52 cards. Okay, so we have 52 cards in a standard deck of cards. So that's what I would have done if I were you. I would have looked it up. So what is the probability it is an ace or a red? Well, okay, if you've never played cards before, you'd have to look up how many aces are in a deck of cards. So I'll go ahead and do that here. How many aces in a deck? 4 aces, okay? Just so you know, I know all these answers, but I'm showing you how you would find it if you did not. So there are 4 cards that are ace, right? What about the red ones? Well, half of a deck is black and half of it is red, okay? But if you didn't know that, you could also look that up. So how many red cards in a deck? 26 red cards, half of the deck of cards, right? So 26 red cards. So I know 26 of them are red. Now we are asked, what is the probability of a card being randomly selected that is an ace or a red card? Okay, so this means that we have to find the probability of pulling an ace, plus the probability of pulling a red card. So first you add the two probabilities together, and then you have to subtract out the probability of grabbing an ace that is a red card, okay? So let's go ahead and see here. Let's see what we're given. So the probability of an ace is 4 cards, but specifically it's out of 52. That's why we had to know the total, right? It's not just going to be 4. 4 what? 4%? No, right? It's not percentage. So it's 4 out of 52 cards are an ace, okay? What about the probability of it being a red card? Well, 26 out of the 52 cards are red. So it'll be 26 out of 52. And now we're looking here, okay, well, what is the probability of both? Okay, probability of both, you have to think, how many of the aces are red? Well, if half of all the cards in a deck are black and the other half are red, if we have 4 aces, that means 2 of them are black and 2 of them are red. You could also probably Google that. How many aces are red in a deck of cards? But we know they are 2. 2 of them are red. Okay? So that is the probability of both, 2 out of 52. All right, so now you have to add that. 4 plus 26 is 30, minus 2 is 28. So our total here is 28 out of 52. That is the probability that we pull either an ace or a red. So obviously the red has a much higher probability, right? The card we pull would probably be a red versus an ace, because there's only 4 out of 52 that would be an ace. But nevertheless, this is the answer to this question. The probability of pulling either an ace or a red card is 28 out of 52. If you wanted to write that as a percentage, we can do 28 out of 52 times that by 100, 53.85 if you were to round it. So this would be 53.85%. And that is the probability somebody would pull either an ace or a red out of a deck of cards. All right. So now we're on to the multiplication rule. Okay. This is given conditional probability. Whenever you're given a condition, and that definitely affects your probability overall. All right, so here we have in Canada, 92% of the households have televisions. Okay. 72% of the households have televisions and internet access. So what we're asked is, what is the probability that a house has internet given that it has a television? All right, so here's what I like to do. I always like to write it out. So probability of has internet given it has a television. So this would be the probability of somebody having both of them divided by the probability of them just having a TV. Because if we know they have a TV, we want to know, all right, how many people with a TV have internet as well? Okay, so this part here, having television, says here 92% of the households have televisions. So that is this probability right here. Okay, and that's what I got here. Given has TV. Whatever you're given goes on the bottom every single time because that's the information you're given and that's what you're focusing on, okay? Only the people who have that. So we're only looking at those people who have a TV, and that's why it's on the bottom because that's the total number of people we're looking at is right there. And it is written as a percentage. So it's 72 out of 100 people who have, or I'm sorry, 92 out of 100 people who have a TV. That's who we're looking at there, okay? So then the second part is both of them, okay? Not just the internet, but having internet and TV because we're only looking at the people who have TV. So we're like, all right, well, how many people out of those who have TV also have internet? Okay, so this would be the probability of both of them. 72% of people who have a TV also have internet, and we know 92% of people have a TV. So now we have to divide that number, 72 divided by 92. Let's see what we get here. 72 divided by 92. We get 0.7826. And if you wanted to multiply that by 100 to get the percentage, our percentage would be about 78%, or you could write it out as 78.26%. So that's quite a few people who would have both TV or internet given they have a TV. Okay, so that's the number of people who have a TV also have internet. All right. Okay, so number 7, it says, consider the following table giving the contestants in a dog race. So this one's nice. It already has all the totals. So remember, if you're ever looking at a table and they only gave you this info that I'm putting in a box here, you need to add the totals, the column and the row. Okay, this one's nice. It already gives you each of the totals. So find the probability that a randomly selected dog is a basset hound. Well, what you want to do is look at where the basset hounds are. And here we have 22 of the dogs are basset hounds. Well, how many total dogs are there? You want to look at the total of all totals. So it's going to be 44. So there are 44 total dogs. So it appears that 22 out of the 44 dogs are basset hounds. That comes out to 1/2, which is 50% of the dogs in this race, in this dog race, are basset hounds. Okay. Now it says, find the probability that a randomly selected dog is a female. Okay, well, you want to look at the females here. Let's use a different color. So here we have females. The total number of females is 20. Okay, so we know 20 of the dogs are females and we have 44 total dogs. So we could divide that. 20 divided by 44, we get 45. So 4,500 is repeating essentially. So if you were to multiply that by 100, you're going to get about 45.5%. Okay, if you were to round that. So this is about 45.5% of the dogs in this race are female. So now it says a basset hound given it is a female. Okay, so we have to look at only the females, right? So we know it is a female. Has to be a female. So the total here is 20. So since it is a female, this is going to be out of 20. You can also use your little conditional probability rule up above. It's the probability of it being a basset hound out of the probability that it is a basset hound and a female. Okay, or I'm sorry, the top part is the probability that it is a basset hound and a female, which is going to be right here, a female basset hound, out of the probability that it is a female, because we know it's a female. So we know there's 20 females here, and only 12 of them are basset hounds. Okay, so here, if you wanted to divide that to get the percentage, 12 divided by 20, 0.6 times 100, 60%. So there is a 60% chance that a randomly selected female is a basset hound. So now it's saying, all right, what is the probability that it is a male given it is a boxer? So now this changes things up a little bit. We are only looking at the boxers. We know it is a boxer, so I'm looking only at the boxer column here. Okay. So the total number of boxers are 22 boxers. And we want to know, okay, how many of them are males? Well, if you look here, so these are female, so it's not that one, males. So 14 of the boxers are male. So this is 14 out of 22. And this is essentially how the equation up above works. So the probability of some event A or something A given something B is the probability of both of them, both A and B, over the probability of just B. So in this case, the probability of just B here was the probability it was a boxer. 22 of them were boxers total. Okay, but only 14 of them were a male boxer. So that's how we got these numbers here. If we want to write that as a percentage, we do 14 divided by 22. We take that answer, times it by 100. You can round that to 63.6%. Again, guys, just to remind you, I am going pretty fast, all right? I do not expect you to be able to work at this speed, so make sure you are pausing the video as we go. All right, number 8. A survey of 200 recent high school graduates found that 170 had driver's license and 108 had jobs. 21 graduates said that they had neither a driver's license nor a job. Draw a two-way table to represent the situation. All right, so first of all, 200 total recent high school graduates. 170 of them had driver's license. 108 of them had a job. 21 of them had neither a driver's license nor a job. Neither one. So it wants us to draw a two-way table. So you might think, okay, well then it's a 2 by 2, right? So let's think here. So we're talking about driver's license and jobs. Okay, I'm going to shorten driver's license and just write DL for driver's license. So it's either that they had a driver's license or did not have a driver's license. And it's either that they had a job or they do not have a job. So this is how you would set it up. And then you would realize, oh, I need a total row and column for this problem. Anytime you have a table and you're talking about probability, you're definitely going to want a total, row, and column. Okay, so let's see what we're given. It says 200 recent high school graduates. So where would I put that 200? That's what you want to ask yourself here, is where would I put the 200? That is the main total. So the 200 number goes right here. So this is your first step, is to start plugging in these numbers that we have into our table. So pause the video and try it out on your own. I know you can do it. You can totally do it. Give it a shot. Okay, hopefully you tried it. So 170 had driver's licenses, okay? So driver's licenses, the total number is the 170. So that number here needs to go right here in the total number of students who had driver's licenses. 170. And 108 in total had jobs. So now pause the video if you didn't get it before on your own. Try this one out on your own. So here, 108 had jobs. So job, the total will go right there. So 108 had jobs in total. And then it says 21 graduates said they had neither a driver's license nor a job. So we're looking at the two no's. No job, no driver's license. So if we were to draw a line, where do those two intersect? That was a horrible line, but still intersected there, right? So it's going to be this one right here, this box there. That is the 21 graduates who do not have a driver's license and do not have a job yet. So 21. So now if you look at this, you need to fill in the blanks, okay? So the first two blanks you're going to want to do are these two here. So we know here, these numbers here represent job and no job. The 108 and whatever the other number is the number of students who have a job plus the number of students who have no job. So if we have 200 total students and 108 of them have a job, how many of them don't have a job? We have 200 students and 108 of them have a job. That means 92 of them do not have a job. You can just do 200 minus 108 in your calculator and you should come up with the answer. So now do this one. If 170 kids have a driver's license, how many do not have their driver's license? If there's 200 total students that are being surveyed here, 170 have it, how many don't? If there's 200 total, 30. 170 have their driver's license and there's 200 of them, so that means 30 of them do not have their driver's license. And now you can fill in the missing pieces here, here, and here. The first two you have to do are this one and this one. Okay, so you can do either one first. Let's look at the students here. So the top box is job and no driver's license, and this one is no job, no driver's license. But we know that the total of students who do not have their driver's license is 30. So how many students have a job but no driver's license? 9 plus 21 is 30. So 9 of them have a job and no driver's license, and 21 of them have no job and no driver's license. So this whole column here, this whole column here is just no driver's license. That's what this one represents. And now we have to start going sideways. So this one here is those students who have a job. So these first two boxes need to add up to 108. So this box here are the students who have a job and have a driver's license. And this box here is they have a job, but they don't have their driver's license. So they either ride their bike, they get dropped off, or they have to take a bus. Those are the kids in this box. Kids, I guess they're technically adults now, right? Because they're high school graduates. But 108 minus 9 is going to be 99. So if 108 total kids have a job and 9 of them don't have a driver's license, how many of them do have a driver's license? It'll be 99. So now you can find this box by either looking at all the students who don't have a job or by looking at all the students who have a driver's license. Okay, so I don't really mind either way. Let's just go ahead and do the no job one. So how many students do not have a job but do have their driver's license? Well, we know 21 of those without a job have do not have a driver's license. Sorry, do not have a driver's license. And there's 92 high school graduates total who don't have a job yet. So, how many of those students have their driver's license? Well, 92 minus 21 will be 71 students. And then you'd want to make sure, okay, is 99 plus 71 170? Yes, it is. All right, so now we totally filled in our blank to the two-way table, and this part of the problem is done for number 8. So now it says, if one of these 200 graduates is randomly selected, what is the probability that he or she has a job and no license? So he or she is just the person. So you could literally change that to they. What is the probability that they have a job and no license? So really what we're looking at is have a job and no license. So what is the probability that somebody has a job and no driver's license? Well, we want to look here. Just one person at random. This has no formula. We just have to look at our table. So job is this one here, job, and no driver's license. No driver's license here, job here. Where do those two intersect? Well, they intersect right up here at the top. So this is going to be 9 out of the 200 graduates. If one of these 200 graduates is randomly selected, 9 out of 200, that would be full credit for your answer right there, okay? So you guys would have to use the table to try to find out how many students have a job but no driver's license, right there, okay? You'll notice that information there was not given to you up here, so you needed the table to figure that out. So if we wanted to write that as a percentage, totally could. 9 divided by 200, and then multiply that answer by 100. We get 4.5%. So not many of them, right? It's a really small percentage. So this is 4.5%. It's only 9 out of the 200 graduates who have a job but no driver's license, because it's pretty rare that you get a job and you don't have your driver's license, but it's definitely possible. They might just be waiting on their test, or they like riding their bike, you know. But this would be the probability of students who have a job with no driver's license. Alrighty, if the randomly selected graduate is known to have a job, that is a given. We are given that info. What is the probability that he or she has a license? So here it is. What is the probability somebody has a driver's license given we know they have a job? Driver's license given job. The given, if we're given something, right? If we're given something, that is the multiplication rule. So that's up above here. That is this rule right here. It is the probability of A and B, or the probability of both, over the probability of just B. So let me see if I can go ahead and copy this for us here. Copy. I'll put this down here. All right, so it's probability of A and B over the probability of just B. Okay, so if we have A given B, the B part is what we were given right here. We know somebody has a job. Okay, let me just make that a little bit smaller. All right, so this is equal to the probability of DL and job, right? DL and job, or you could have written both, as long as you know that that's what you're talking about, over the probability of a job. We know they have a job. So let's see here. How many total kids have a job? How many total recent high school graduates have a job? Job total. 108 total kids have a job. Okay. Oops. 108. All right. So now we have to look and see, okay, well, how many of them have DL and a job? Driver's license is the DL part. So how many of them have a driver's license? So driver's license is here. And how many of them have a job? Job is here. All right, that is 99. It intersects right here. 99 of them who have a job have a driver's license. So this one here is 99 out of 108 because we're only looking at those who have a job. 108 of them have a job, and 99 of those 108 have a driver's license. So this is the probability that a student who's randomly selected has a license, given that we know they have a job. Okay, so if we wanted to find that percentage here, we do 99 out of 108. That is about 91, and then the 6 is repeating. Or 9100, sorry guys. So this is about 91.7% if you were to round it. Okay? That is the probability that if we selected out of all the students who have a job, that's the probability that that student would also have a driver's license. All right, now we're almost done. Okay, 2 more problems. These are on expected value. So first of all, you need to write the fractions for the spaces here. So this is the only one you know. You know this one is 30 degrees. We know the other one's $4, right? This one's $9. But what I mean by that is that this one is 30 degrees. Well, a circle, right? How many total degrees are in a circle? 360. So this is 30 degrees out of 360. So that should give you enough information. What are the rest of this? How many degrees is the rest of the circle? If that green part is 30 degrees and the entire circle is 360 degrees, what's left? So it'd be 330 degrees would be the rest of the circle. So to find the expected value, you take that fraction, okay? The fraction here is 330 out of 360, and you multiply it by the value of that section. The value of that section is $4. And then we add it to the other fraction multiplied by the value of that section, which in this case, this section was $9 worth. All right, so then if you remember to multiply, you have to put this over 1, but we can also simplify a little bit here. So you guys see here, 330 over 360, we can cross out the zeros. So then we're left with 33 over 36. But then you can also divide top and bottom by 3, and we could go through all that and simplify it if you wanted to. However, you don't have to, okay? You do not have to. We could leave it like this. We could do 330 times 4, all right? So let's go and do that. 330 times 4 is 1,320. And yes, it's a big number, but we have calculators for that. So 1,320 over 360 times 1, 360. 30 times 9, okay, is 270. Sorry, big yawn. Over 360 times 1 is 360. Okay, so now we have to add the tops. So we have 1,320 plus 270. That's going to be 1,590 over 360 because they both have the same denominator, so that's why I can do this. Now if we take that, so we take 1,590 divided by 360, this is our expected value. So this one is about equal to 4.42. Okay. And now we're talking to be dollars. So like if we were to play this over and over and over again, we would expect to win an average of $4.42 per game. So this here is the expected value. All All right, this one looks like a little bit more of a challenge over here, number 10. Okay. There we go. All right, so I'm given that this part is 60 degrees. So again, that's 60 out of 360 degrees. Okay. This part up here is 90 degrees out of 360. And since this is on a straight line and half of it is 90, it means the other half is 90 because a straight line is 180 degrees. 90 plus 90 is 180. All right, and then this guy here, this is on a straight line. And we know this part here is 60 degrees, because that's what it tells me here. So 180 minus 60 is 120 degrees. Okay, so this one here is 120 over 360. Now, you guys could totally simplify down these fractions, but this one would be 1/4, this would be 1/6, and this one would be 1/3. And as you're looking at this, they don't have the same denominator. So then you'd have to go through the process of finding a common denominator, and you can totally do it that way. That's totally fine. However, you can also just leave it as the fraction of the circle, like the degrees out of 360. That works too. So what we're going to do is take the fraction of the circle and multiply it by its value. Okay, so here I'll go ahead and use the same color. So we're going to take those two parts there. So 90 out of 360 times 10. And I wrote it big like that because I know I need to put that 10 over 1 to multiply a fraction together. Okay, and then now here I have 120 over 360 times 9. 9 is the value of that part of the circle. And what we're doing with those is we're adding them together. Okay, this is how we find the expected value. I cannot remember what chapter we did this in, but I know we did it last semester. I just can't remember the chapter. So 120 over 360 times 9. That's that part of the circle. So if it helps you visually too, you could always like do the entire section here with that color if you want. That's fine by me. It's totally up to you how you want to do it, just so you understand it visually and conceptually. So if this makes more sense to you, that's fine. All right. And then we have this section here. Does not matter what order you go in as long as you keep the sections together, right? So this value here is, so this value, and this one was 10, 9, this one is 6. Okay. So, and this green part here is 60 degrees of the circle. So 60 out of 360. So here we have 60 out of 360 degrees times 6. All right, and then the last one here is a 90-degree portion of the circle. Oh, sorry, I went way outside the lines there. Okay, and that one is worth 5. All right, so we're going to take that part, 90 out of 360, multiply by its value, 5, and this is going to give us our expected value. Okay, so make sure you pause the video if you still need to see this visual. I'm going to go down here so I have a little bit more room to work with. This was the blue section. All right, so we have to put each of those whole numbers over 1 if you want to multiply straight across. So this yellow portion here will give me 90 times 100 is 900 over 360. 120 times 9, I couldn't do it. I'm horrible at doing multiplication in my head. What kind of math teacher am I? 1080 over 360 plus 360 over 360, so I'm just multiplying across here, plus 450 over 360. So what I personally would do would be add all the tops, and then you have the same denominator, so all the denominators are 360, right? So you guys want to use your calculator. So we have 900 plus 1080, oops, 80 plus 360 plus 450. Let's see if I counted that right. That'll be amazing if I actually remembered. 900, 1080, 360, 450. Yep, sweet. So we have 2,790. And now I need to divide that by 360 to find my expected value. So my answer there divided by 360, 7.75 should be your expected value. Okay, so now you guys need to go do that Google form quiz and do these types of problems on your own using this review video. All right, expect to see an EST on this topic